Let us solve this problem. A uniform half meter rule MN is balanced horizontally on a fulcrum placed 10 cm from M as shown above. If a mass of 45 grams is hung at the end M, calculate 1. Mass of the rule, 2. Magnitude of the force exerted on the rule by the fulcrum. Now, what we are going to do is that we are going to show all the forces acting on the meter rule. Now, look at this question. I'm going to use a line, just a straight line, to represent this meter rule. So here I'm going to have something like this. Now, remember, we already have a point M and we already have point N. And here we have a mass hanging here, and it is 45 what? 45 grams, right? Now, the question says that we have a fulcrum here. We have a fulcrum here, and the fulcrum is placed 10 centimeters from M. It means that from M like this, from this M to this fulcrum like this, is how many centimeters? 10 centimeters. So you have to do that first. So once you do that, then the next thing is, remember, this is a uniform half meter rule. First of all, let's talk about half meter rule. A standard meter rule is, the length of a standard meter rule is 100 centimeters, right? So the question is a half meter rule. It means that you must know that the half meter rule will be how many centimeters? 50 centimeters. It means that from this M here to this M here, the distance has to be what? 50 centimeters, because the standard one is 100. So half meter rule means that the total length of the half meter rule is 50 centimeters. So from here to here is 50 centimeters. That is clear, because you have to make use of everything this question says. So now, and the question asks us that we should calculate the mass of the meter rule. Remember, we are not done with everything in the question. The question says a uniform. I think I've said this several times. Anytime you are given a uniform object and they give you the mass of that object, you have to put the mass of that object at the center of that object. Or anytime you have a uniform object, they ask you to find the mass of that object. You have to represent the mass of that object with any variable of your choice and put it at the center. Because it is uniform, the mass will always be at the center. So what I'm saying now is that, remember, the total length is 50, so the mass must be at the 25 centimeters. So what I'm saying is, so the question says we should find the mass of the meter rule. So the mass of the meter rule will be at the center of this meter rule. So, and the center is 25 from 25. So let's say the center is here. So we can do something like this, and we can put our M, the mass of the meter rule. And don't forget, it has to be 25 centimeters from both ends. So from here like this, what I'm saying is that from here to this end, that's 25 centimeters. From here, from this end to this place to this 25 centimeters. But remember, we are going to be taking moment about this pivot, about this fulcrum. And if we are taking moment about this fulcrum, we should know the distance of this mass from this fulcrum. Remember, from here to here should be 25. Since from here to here, to this fulcrum is 10, right? So from here to here should be 15, because from here to here is 25. You should be able to do that at least. So here, so from here, from this fulcrum to here is 15 centimeters, like this, right? So once you have done that, then you are good to go. So the forces that are acting here, don't forget, is this, the mass that are acting on this meter rule. We have this 45, right? And we have this, the mass of the meter rule itself, right? So we are not going to change any, anything. We have to take the moment now. You have to take the moment. Remember, this is the fulcrum. This is at the center, like this. This is the fulcrum here, at this point. So this 45 grams we tend to rotate it like this, the meter rule like this. So it's rotating like this. Now rotating like this is anti-clockwise, but this mass of the meter rule, we also want to rotate like this, and that is clockwise. And remember the principle of moment. The sum of, if a body is balanced, that is in equilibrium, the clockwise moment about a point, the sum of clockwise moment about a point is equal to the sum of anti-clockwise moments about the same point. So what is the clockwise moment here? Clockwise, you can say, let's say clockwise moment is equal to, what is the clockwise? So that's m times distance. Remember, we are taking moments about this fulcrum, about this point. So this m times the distance from this point. Remember, distance from this point is 15. So m times 15. So that's going to be what? 15m, right? Remember, this m represents our mass, not meters. So m. So here now, what about the anti-clockwise now? About the same point. So anti-clockwise, I'm going to say anti-clockwise moment. Anti-clockwise moment is equals to, that is 45 times the distance from here to the fulcrum is what? Is 10. Remember? So that's 10. And that is going to give us what? 450. Now, principle of moment. Clockwise moment about a point is equal to the anti-clockwise moment about the same point. So for 15m, it means that the clockwise moment, which is what? 15m, must be equal to anti-clockwise moment, which is 450. So we are looking for m, the mass of the meter. So we are going to divide both sides by 15. So divide this one 2 by 15, and 15 cancel 15. So now we can say m is equals to 15 here 1, 15 in 45 is going to give us 3, and that's 0. So, and don't forget, the mass here is in grams. So the mass of the meter rule is what? Is 30 grams. So the mass of the meter rule is 30 grams. Now, remember, the question asks us to find the magnitude of the force exerted on the rule by the fulcrum. Now, I've said it several times in my videos that at the pivot, there's always a force acting upward. At this point now, there's a force acting upward. Why did we not put it when we are doing this? It is because it is useless. If you had put a force here, you want to find the moment of that force about the same point. So force times distance about this point is 0. So it's not going to count. And that's why, because we don't need it at that point. But now we are asked to find the force at that fulcrum. So we can redraw our diagram. Now remember, we already got this one, right? So I can clean this off like this. I can clean this off. Now I'm going to represent this again like this. Remember, there's 45 grams here. 45 grams, right? So at here, at this 10 point, we have what? We have a force at this fulcrum acting upward. Now, support. This coming down, this going, this support it. So meaning that there's a push upward, and that's why the force at the fulcrum is always acting upward. Don't forget the mass of this meter is here. So we have the mass of the meter, we got it the other time, which is 30 grams. So 30 grams. So the reaction here, that is the question saying magnitude of the force exerted on the rule by the fulcrum. So let's say the force here is, let's represent it with F here. So how do we know the force here? Well, what we are going to do is that we are going to apply the condition for equilibrium, which says that the sum of upward forces is equal to the sum of downward forces, or even like the sum of forces in one direction equals to the sum of forces in the other direction. So what we are saying is that look at this 45 gram coming down, this weight, this mass of the meter will also coming down, right? But this reaction is the one going up. So the one going up, F, is equal to this one coming down, and we have two coming down. That's 45 plus 30. So that is going to be how many grams? That's going to be 45 plus 30, that's going to be 75 what? 75 grams. Remember, the question requested for the force So we have to put it in Newton. First of all, we change it to what? We are going to change it to kilogram. We can change the gram to kilogram by dividing it by 1000, right? So after changing it to kilogram, we multiply it by 10 to do what? To change it to Newton, right? So we are going to say this 75 divided by 1000 first. This change it to what? Kilogram. Then multiply by 10 to change it to force, or if you like, weight. So that is going to be 0 cancel 0 here, and this 100 is going to be like 1, 2. That is 0.75 what? Newton. So the force at this fulcrum is what? 0.75 Newton. Thank you.